All right, back as promised, here we are to finish solving this truss problem. So after you solve for your external reaction forces, now what we need to do is we look at each, using the method of joints here, each individual joint or point here is going to have its own free body diagram. And the best recommendation I have for you on where to start is choose a spot where you have the least number of unknowns. So in this case, because we just calculated for FCY, FAY, and FAX, and if we look at this point, we have a beam here and a beam here, and then we have a beam here and a beam here. These two are probably our best points to start from. So I'm going to start at point C and calculate my values there. Okay, so point C. So my free body diagram at point C will look something like this. I'll draw a point, and I'll draw the force that I know is acting on it. So that force is FCY, and that's acting up. Now to draw the rest of my forces, I will draw lines and replace my beams with forces. So I would have a force going up and to the left like this, and I would have a force going left like this. Now which direction should my arrow be pointing? Because this is the only component or the only force that would have a y component, I'm going to say that this is going down and to the left because my other force is going up. So then I have one coming down, or down and to the right. So this would be down and to the right, this one would be up. So I'm going to say this is coming down and to the right, and since this is coming to the right now, I'm going to assume that this is acting to the left to cancel that out. So now that I have my forces here, I can label them. This one would be force BC, and this one would be force CD, if you want to stick in alphabetical order. It could be DC or CD. Either way, they're the same. So now I use my equations of equilibrium to solve for these forces. So some of the forces in X equal to 0, and that's going to be equal to FBC times the cosine of theta. So if this was theta up here, the cosine of theta would be my adjacent time, or divided by my hypotenuse. Now I don't know what my hypotenuse is, so I'm going to pause it here quick and solve it. Okay, so I'm back. So my hypotenuse ends up being 8.06 because I did 4 squared plus 7 squared and took the square root. So the equation for cosine of theta, since I don't know this angle, I can take FBC times the cosine of theta, which is the same thing as saying 7 divided by 8.06. So I'm going to take FBC times 7 over 8.06, and then that will be minus FCD. I can't solve that yet, so I'll go here. So I'll say sum of my forces in Y equal to 0, and that's going to be FCY, which I just calculated to be 150, minus FBC times the sine of theta, which in this case, sine would be 4 over 8.06, opposite over hypotenuse, 4 over 8.06. And so with that, I get FBC is equal to 150 divided by 4 divided by 8.06. And I get FBC equal to 302.3, let's call it. Now there's one last thing that we add into our truss calculations, and that's when we have our internal forces here. We need to state whether these are compression or tension. So because I got this and as a positive answer, then I know I guessed right on my direction here. And anytime your arrow is pointing away from your joint, that is going to be a compression force. So anytime it's pointing towards your joint, that's going to be considered a tension force. So I need to label this as compression. So I just put the letter C by it. So FBC is in compression. So now that I know that, I can plug that back in up here, and I can say 302.3 times 7 over 8.06 minus FCD would be equal to 0. So I'll just write this down here. FCD then is going to be equal to 262.5. And that one would be in tension. So once again, pointing towards it, it's in tension. Away from it, it's in compression. And because I don't have an angle, I use the formula for sine of theta and cosine of theta. So cosine, remember, is adjacent over hypotenuse. Sine is equal to opposite over hypotenuse. Okay? So now I have C done. So I'm going to move over, because now I know CD, and I know this 500, I'm going to go and use point D next. And I'll do that way over here just to give myself space to work backwards. So point D, I've got CD, and if it's pointing away from the joint in this one, it's also pointing away from the joint in this one. So that means that we're going like this. My 500 pounds is pointing down, so I'm going to point up on this one. Okay, so back to this. I've got 500 pounds pointing down. I've got FCD here, which I just calculated. I've got FBD going up, and FAD off to the left there. So if I go some of my forces in X are equal to 0, I get FCD minus FAD. I can plug in from over here, 262.5 minus FAD. So I know FAD is equal to 262.5. And because that's acting away from the joint, I know that that is in tension. My other one, so my forces in Y, would be FBD minus 500. So FBD is going to be equal to 500 pounds, and that also will be in tension. Okay, so I've got 1, 2, 3, 4. So I've got BC, I've got CD, I've got BD, I've got AD. The only one left to figure out is AB. So since I only need to figure that one out, let's just go to joint A to finish solving this. So at joint A, I'm going to have FAX, which I now know to be equal to 0. I've got FAD, which is going away, and that is at 262.5. I've got a force here that, since this is going to the right, I'm going to say that that has to be going down and to the left, also because I know this is going up. So FAY I know is 350, and so I can solve the rest of this using my systems of equations. F of x is equal to 0 is equal to 262.5 minus FAB times, up here, if it's my x, I'm going to use 3 over 5 So I can solve right away. FAB equals 436.7 pounds, and that one, since it's going towards my joint, is going to be in compression. So there we have it. I didn't even need to use all of my joints to solve for all of my forces. So I've got all of my external reaction forces, and with that I've solved for all of my internal reaction forces using the same equations of equilibrium. I just need to finally state that they are in compression or tension. There's a lot of work going on here. Watch it again. Try to go through it. Pause as you need. And we will continue talking about this as we come back to class.